Very closely related to disaster recovery is high availability. High availability is a system design approach that ensures systems or components are continuously available. Essentially, availability is of the utmost importance to organizations. Organizations need to have applications and services available to end users at all times. Why? Because if end users can't access the service or the application, then we have what is called downtime. And downtime technically comes in two different fashions: scheduled downtime and unscheduled downtime. Scheduled downtime is downtime that's actually been predefined, usually in a service contract, that an administrator, or it allows, an administrator to perform routine maintenance. So installing critical updates, doing firmware upgrades, service packs, upgrading applications, etc. Even doing hardware maintenance is sometimes considered scheduled downtime. Unscheduled downtime involves the interruption to a service due to a failure, a physical event like a power outage, hardware failure, security breach, those kinds of things. Most organizations are going to exclude scheduled downtime from their availability calculation for an application or service. So as long as the scheduled maintenance can be done in a way that it doesn't impact end users, then it's not a part of the overall availability that they consider. And that's making sure that an IT organization can meet the availability requirements and that an application or service is always available to the users is really a critical component to the organization. We have to guarantee a certain level of availability, and it's usually measured in the states of nines. So a system is 99% available, or it's 99.999% available. And in order to achieve that, IT administrators are going to implement the concept of fault tolerance. Fault tolerance is just going to allow a system to function as normal in the event of a failure of one or more components. So fault-tolerant systems are designed for high availability and reliability by installing multiple critical components, or I've always said just identifying and eliminating single points of failure. If you look across a system and you say, okay, if this one component were to fail, then it would bring the system down, then that's a single point of failure, and I have to implement duplicates, or as we said in the previous section, redundancy, right, for that. So for example, you got a hypervisor. That hypervisor would have multiple CPUs because if one failed, it would bring the system down. It would have multiple power supplies, multiple hard disks, multiple NICs, possibly multiple memory chips, right? So that if one of the components were to fail, the spare component could then take over without bringing the system down. Now, obviously, the greater the fault tolerance, the greater the expense, because we're talking about redundant components. If we remember, the definition of redundant was something that wasn't actually necessary, right? To say that is slightly misleading, because I do need it to implement the level of fault tolerance that I'm trying to implement and the level of availability. But in normal cases, it's not needed. And so these redundant components are simply going to add to the expense of the system as a whole. Now, in addition to adding components to achieve fault tolerance in an individual system, it's also possible to implement two redundant systems that act as a single computer. Now, we sort of alluded to this earlier when we were talking about failover, because this is generally referred to as clustering, or simply put, a failover cluster. This provides parallel processing. The computers are connected over a fast local area network, and each node is technically running its own operating system. So they're independent of one another. They can operate independently, but they work collectively as a quote-unquote virtual server. And I hesitate to use the term virtual server because we're talking about cloud computing and virtualization, but that's not what we mean. I just mean it's a server for a particular application, okay? And so that particular application can be active on one cluster node. If that cluster node has some sort of failure, then failover ensues, and it can be active on the other cluster node. There are multiple advantages to failover clustering. clusters will improve performance because they can be configured in a load balancing mechanism as well. All right, so the failover cluster is not always in an active-passive type of arrangement where the redundant system is just sitting there doing nothing until there's a failure. That is an option for failover clustering, but it's not the only option. Another option is active-active. And in active-active, you have multiple nodes that are servicing client requests all at the same time. At that point, if one of those nodes fails, then the other node's performance will be slightly degraded, but the system would still be up and running. Okay, it obviously then improves fault tolerance. It improves fault tolerance at multiple levels. I mean, we probably already have redundant hardware in the servers themselves, but even if we didn't, then this facilitates, protection against a hardware failure. It facilitates protection against operating system failure and protection against the application level failure. Okay, so it will give us fault tolerance. The loss of an individual component may degrade performance, but would not cause the system to go down. In addition to local clustering, there is also the ability to use geo-clustering. This is an alternative that allows for the connection of multiple redundant computers when those computers are located in physically different places. So instead of having the nodes connected over the local area network, they're connected over a wide area network, but they still appear as a single highly available system. So geoclustering is going to allow you as an organization really to support enterprise level continuity, because now we have systems that are location independent. All right, and this is not only available in the cloud, this would be available for on-prem scenarios as well. Another important thing with high availability is to kind of move our focus outside of the systems themselves and to the infrastructure. Having an infrastructure that is redundant and highly available is going to be very advantageous to the organization because it helps you to provide a consistent environment, more productive workforce, etc. But it's going to take some planning because we have to determine the systems that are requiring the investment to be highly available. There are going to be some systems and applications that it's not appropriate for. Why? Because it's expensive, and you don't necessarily need this for all applications. Another possibility is that you deal with an application that does need high availability, but can implement it in a more cost-effective way. Okay, and again, I will use Exchange, Microsoft Exchange, as an example for that. So we don't have to implement failover clustering. We don't have to have the expense of a storage area network with Exchange, and it's just because of the way that high availability is implemented in Exchange. Another example would be the public cloud model. Okay, so an organization, a small to medium-sized organization, considers the public cloud model as a means to enable high availability without the added expense for critical applications. What do we mean by that? Well, when you use the public cloud model, then the cost of making the systems highly available doesn't fall on you anymore. It falls on the cloud provider. So it allows the consumer to take advantage of highly available systems. If it's not highly available, then it's a breach of contract. Okay. So, those kinds of things come into play, and you have to think about it. Let's look at this application. Let's evaluate the necessity of availability. Let's evaluate the level of availability that's required. And then let's determine if we as an organization are capable of implementing that level of availability. And I believe I said this at some point. That's one of the reasons to go to the cloud, is because small organizations will look and say, no, there's no way. I can't implement the same level of availability that a public cloud provider is going to implement. It's going to cost me way too much, be too much effort, or we don't have the know-how, or all of the above. And so for that reason, we're going to go with the public cloud provider because they inherently will provide this capability. Okay, so just keep that in mind because it is one of the big benefits. A couple of other terms that come into play with high availability here that we need to be familiar with. One is multi-pathing. When you have a fault-tolerant system, that's a great start if you're just talking about internal components to the system, but it is just that. It's a start. It's not the only requirement. Really, you have to consider all aspects of the network, and all aspects of the network need to be highly available. And so, when we're planning for high availability, it's best to always start by looking at the entire solution and saying, are there any single points of failure? Because if there are any single points of failure anywhere, then that is the chink in the armor, so to speak. Okay? So if you have a connection, a single connection that exists between fault-tolerant systems, or a single connection to their storage, that's going to be a single point of failure. It's limiting the high availability of the system. So simply put, multipathing configures multiple paths to storage devices. Okay? It provides redundancy for the system to connect to the storage devices. The most common type of multipathing is actually called MPIO, multipath input-output. This is a feature that's installable on Windows servers. It's used, with iSCSI and fiber channel SANs. It does require multiple physical paths to the storage device, but then it requires just a single HBA. And so you can configure the HBA to send traffic across the multiple paths. Ideally, that means that if one of those paths were to be unavailable for whatever reason, we could still access the storage device. Therefore, the system is still up, it's still available, because we've introduced redundancy even at the network level. Another form of high availability that you should be familiar with is load balancing. Now, sometimes we just use the term load balancing as just sort of a generic term. And technically, I've got load balancing if I've got multiple domain controllers or multiple DNS servers, but that's not really the way that it's being used here. Here, it's being used in terms of high availability. So we're saying it's a different form of high availability, one which distributes the workload across multiple computers, multiple networks, multiple disk drives. So load balancing is going to help to optimize workloads. I said those things. Optimize workloads and resources. Load balancing is going to help to allow for maximum throughput. It's going to help to minimize response times for the end user, and it is going to provide some fault tolerance. But the primary purpose that we have is twofold: increase performance and provide fault tolerance. So more than one system responding in kind will increase performance. If one of those systems go down, then the other systems can pick up the slack, and there you have your fault tolerance. The difference between load balancing and failover clustering is often where they're implemented. So load balancing is a form of high availability that is implemented most commonly on front-end servers like web servers, whereas failover clustering is implemented most commonly on back-end servers. Those would be the servers that actually have the data. So hypervisors in a cloud environment, database servers, those kinds of things. Those would be failover clustering nodes. Web servers would often be the load balancing nodes. There are a couple of different types of load balancing that exist. The first is software load balancing. Software load balancing would be a role or a service that's implemented on the server. The feature in Windows is called NLB, or Network Load Balancing. And you can install that on multiple servers and create an NLB cluster. The NLB cluster then has a virtual IP address assigned to it, and each of the cluster nodes are subscribing to that IP address. Along with that IP address, there are what are called port rules that determine, okay, when connections come in on, say, port 80, we're going to distribute that traffic to each individual node. The nodes communicate with one another via heartbeat signals, and that's how they know whether a node is overloaded or a node is inaccessible. NLB is pretty easy to implement, but it's got some downfalls, and so a lot of people, a lot of organizations will opt to go with hardware load balancing. With hardware load balancing, you actually have a physical device, and it's that device that hosts the VIP or the virtual IP address. It is that device that then distributes packets on an as-needed basis to the cluster nodes that are behind that load balancer. It provides a more scalable alternative, but it is more costly because it is an additional device that you have implemented. Now, in some cases, in addition to using load balancing, organizations may want to implement a mirror site. A mirror site is either a hosted website or a set of files that reside as exact copies of one another on multiple computers. And so what the mirror copy does is it makes sure that the website or files are always accessible from multiple locations. So that, of course, increases your availability. That can reduce network traffic on the original site. But these mirror sites have to be updated on a regular basis. Now, you've probably seen a mirror site if you've ever downloaded something on the internet. You go to somewhere like downloads.com and they'll have several different mirrors. I have a certain program that I get for burning ISOs, disk images, and they've got 7 mirrors for me to choose from, and they're geographically separated. And so the mirrors may be, just so that users can hit one that's in close proximity to them. You're in the United States, you have 3 mirrors to choose from. You're in Europe, you have a couple more mirrors to choose from, things like that. But enterprise-sized organizations can utilize the concept of a mirror site to make their information available. You would need some sort of automated replication in order to keep that information up to date.